afternoon, everyone. Welcome to today's seminar hosted by the Center for STEM and Higher Education, the Faculty of Education. I'm Shin. It's my great pleasure to chair today's seminar. Today, we are truly honored to have with us Professor, I hope I can speak very quickly, Professor Jeremy Probasa. Okay. From the FED-CSAE University of Mahara, from Brazil. Okay, first, please allow me to briefly introduce Professor Rosa to you. Professor Rosa is a distinguished scholar in mass education with a rich academic background that includes a PhD from São Paulo State University in Brazil and postdoc research experience at several prestigious institutes, including the University of London and the University of Calgary. He leads the Mathematics Education Observatory Research Group in Brazil and has contributed extensively to the field of mathematics education through numbers of publications and leadership roles. In today's talk, he will share with us his research on the topic of mathematics teacher educators' expertise. For some master and PhD students here, mathematics teacher educators nowadays is also a core topic in math education and I think also in general teacher education. Okay, everyone, please join me giving a very warm welcome to Professor Rosa.
Can you hear me? Good morning, everybody. Thanks, Sharon, for the introduction. I'd like to thank you, especially Professor Fan, for making my visit possible. I'm very happy to be here sharing my current research. So, as you can see, my name is Jonei Barbosa from the Federal University of Bahia. This university is located in the northeast of the country, on the coast. So it's the biggest university in the northeast region of the country. I'm going to share with you preliminary findings from this ongoing research project that I started in 2023. As Sharon mentioned, this is a hot topic in mathematics education research. There is a growing interest about mathematics teacher educators, MTs, particularly in the last 7-8 years, which is quite natural because the area of mathematics education has been researching mathematics teachers, knowledge conception since the 80s and the 90s. Maybe there has been great interest on how mathematics teachers do their work. So it's natural to think, who are the professionals who educate the teachers? So now that's why the interest. If you look at the literature, the authors who are researching on MTs, they had been researching on mathematics teachers. So basically they are expanding their research agenda. Okay, by IMT, what I mean? I mean those responsible to support research in mathematics teachers in mathematics teacher education programs, but also those experienced teachers that act as mentors or tutors at schools. So everybody who is in this position of supporting mathematics teacher learning, development, is understood here as IMT. Okay, so the first steps in this area were based on the research on mathematics teachers. So from these fields, we assume mathematics teachers have a distinct knowledge. Making the same assumption for METs, we assume METs have a distinct knowledge. So as a result, we need to understand what is this knowledge, what METs knowledge are. So it was the first steps in the area. For example, some authors developed theoretical models derived from teachers' knowledge models. For example, probably everybody here is familiar with Deborah Ball's model, which is named the mathematical knowledge for teaching. One development was to, based on this model, to develop a knowledge, MET's knowledge model. For example, MEKTT. It was particularly well developed by Alison Superfine from the US. So in this model, she and her colleagues developed domains of knowledge that METs hold. So this was one kind of development. Another one is based on José Carrillo's model. I'm not sure if you are familiar with this model. The name is Mathematics Teachers Specialized Knowledge. It was developed by José Carrillo and colleagues, and a group of researchers in Italy. Based on this model, they developed this new model, basically adding new domains of knowledge for METs, which is common between both developments. Both assumes METs have a kind of meta-knowledge on teachers' knowledge, which is quite natural to assume it, because if you say teachers need to know more than students know, of course, METs need to know more than teachers know. So this is an important result. Acknowledge METs have a meta-knowledge on teachers' knowledge. But there is a problem with this approach, because maybe if we rely on adaptations or expansion of teachers' knowledge models, maybe there are aspects that fall outside these models. Maybe we are missing some aspects. That's why there is a new development in the area, which is the notion of expertise. A little bit different from knowledge-based categories. This idea of expertise tries to look at what METs do, not only in terms of the knowledge, but in terms of the settings where they develop their work, and also in terms of the material conditions they work. This discussion has been present in the conference, for example, in 2019, 2021, 2022, and the last evening in Sydney, there was a discussion group about MET's expertise. This is where my work is situated. I'm part of this effort to develop this idea of MET expertise. So I got inspiration from the Eric's definition. For me, expertise is understood in terms of professional performance within the domain of practice. If you look at this definition carefully, you notice we are not talking about knowledge. We are talking about what the actions, the performance. So it doesn't mean METs doesn't have knowledge, but the border between the knowledge and the actions, is not clear. They are intertwined. Based on this idea, Oliver Chapman for the University of Calgary and I, we developed this definition of MET's expertise in terms of how these professionals organize and carry out oral and written pedagogical communication with prospect or service teachers to support their learning. So if you look at this definition, our focus is on MET's communication with teachers. It's clearly different from the previous approach that was based on knowledge categories. Right now, I'm still working on this definition, and I'm very inspired by a British sociologist called David Bernstein. I don't know if you are familiar with him, but in his work, he theorizes about the communication between who is set to teach and who is set to learn. So, for example, the relationship between teachers and students is a pedagogical relationship. And there is here a pedagogical communication because the teachers are set to teach and students are set to learn. The same kind of relationship exists between parents and children, between METs and teachers. So then I try to advance this perspective on MET's expertise, putting focus on pedagogical communication. So then my theoretical assumption is the relationship between METs and the teachers are based on pedagogical communication, because METs have the responsibility to support teachers' learning. So this is my current definition. It's still in progress, so it's provisory. It's my current definition. MET's expertise refers to the specialized pedagogical communication that these professionals perform in their relationship with teachers. So then my focus is on MET's communication. Following Bernstein's steps, I'm concerned about what METs communicate and how they do that. So there are two important dimensions: what and how. Okay, so in 2023, there was a great opportunity to explore MET's expertise, because a group of experienced Brazilian METs were invited to produce booklets to support research mathematics teachers and the new METs. So I saw it as a great opportunity because these materials, these curriculum materials, they are a kind of end point into MET's expertise. And there were, I'm going to show you later, there were 20 booklets. And for each booklet, there were two versions. One for teachers, the other one for METs. So then, in these materials, the experienced METs are communicating not only with teachers, but also with new METs. So then the purpose of the study was to identify features of MET's expertise based on the written pedagogical communication in form of booklets for prospective teachers and new METs. 3, a new public university was founded in Brazil. It's the Federal District University, located in Brasilia. Brasilia is the capital of Brazil. And when they opened a public selections of MTs, the people who were selected, they held master and PhD in applied mathematics. And they didn't have any experience with teacher education. That's why the university funded a group of 10 experienced MTs across the country from different universities, including myself, to produce these booklets as a kind of examples for the new MTs to get inspiration, the kind of approach they could use in their classes. These booklets covers topics like numbers, algebra, geometry, statistics, probability, and measurement. These are examples of these booklets. Probably you can't read, but you can recognize similarities with the English language. You can see function here, functions, area, geometry, spatial geometry, area, rational numbers. So there are 20 of them. As I said, for each booklet has 2 versions. One for teachers, the another one for MTs, which is expanded. There are comments, there are suggestions, there are justifications for the tasks proposed. Okay, then this analysis was made by me and Oliver Schaffman. So we went to these booklets trying to identify what the authors communicate in these booklets. And we categorize it in 3 so-called scopes of communication. We named it scopes of communication, or areas of communication. Remember what I said about Bernstein's emphasis on to analyze what and how to communicate. In this analysis, we try to figure out what they were communicating. And we found 3 scopes of communication: mathematics, teaching mathematics, and academic research. If you look at these booklets, these 3 scopes are not present in all of them. In some booklets, for example, just find one of the scopes. But there are booklets you can find all of them. And also, we found articulation, connection between these scopes. So, okay, I'm going to show you examples of these 3 scopes in the articulation. Can you read? Okay. In this example, you see a mathematical task. Its aim is to deepen teachers' understanding of mathematics or a concept of mathematics, even though this task could be used at school. It's not clear the connection with school mathematics. So when this kind of task is proposed in the booklets, it is presented just to improve the teacher's understanding of math. But there is not a clear connection with their future teaching practice. In this case, this scope of communication targets to deepen teachers' mathematical understanding without any explicit connection to school mathematics. On the other hand, when you have mathematics addressed here you see like a simple mathematical problem, a student solution, but also a few comments about the student solution. So this kind of passage in the booklet or task, you see mathematics, but it is clearly connected to teaching mathematics. That's the difference between the two scopes, mathematics and teaching mathematics. The scope of mathematics, you address mathematics itself, but in the teaching mathematics scope, you address mathematics connected to school mathematics. And the third scope is academic research, is when the authors address research findings explicitly. Because sometimes, you know, the authors, they produce the materials inspired based on research findings, but it's not explicit in the text. In this case, it is explicit, because you can see the citations here. So it's a comment, and here you can see the citations, and these citations are research papers. The same here, in this task. 3 articles are presented, and the task is presented to the teachers to do something based on the reading of these 3 articles. So in this case, when academic research is addressed explicitly in the text, in the communication, we call it academic research. Okay, now maybe I would say this finds so far, it's common, it's nothing special about that. But the most interesting part, and I'm so excited about, is when the authors, they connect the scopes of communication. Like in a same passage, they bring together different scopes. They try to articulate mathematics with teaching mathematics, or teaching mathematics with academic research. So they try to establish connections between these scopes. It's quite interesting. Like this, there is a simple mathematical problem, very, very common, but also it is connected to a research paper here. And also it is connected to comments about implementing this kind of task in Classroom here. So then you can see the author in this passage. They were able to connect the 3 scopes of communication. When it didn't happen in every booklet, we found it just in a number of the booklets. But when it happens, we name it as bridge building. So the MT building bridges between different scopes. So then these scopes talk about different what MTs communicate and how they might connect these scopes. So the follow-up question is how bridge building appeared in these booklets. Then recently I carried out another analysis, try to understand the ways bridge building might be enacted. So then I developed a categorization. The first one is in terms of the number of scopes. So for example, if you consider this mathematical task itself, and here, in the following, the author presents a comment, but this comment is based on the research literature about inquiry-based tasks. So in this case, you know, the connection is between 2 scopes. I named it by author. But when the authors, they articulate 3 scopes of communication, like this, so they are based on a research paper, teachers are asked to transform textbook exercise into inquiry-based tasks. So they are invited to engage with this transformation from textbook exercise into inquiry-based task. So then, when you look at this, we see the three scopes in a sequence. It's trimodal. Another categorization is in terms of arrangement. So it might be sequential, as I just said, but also it might be integrated. Because when you look at this task, it's just one task. The teachers are invited to read a research paper, to discuss it, and to do this task, transforming exercise into inquiry-based tasks. So two scopes are integrated here. So then it might be sequential or integrated. And the last one, in terms of purpose, when you look at this this part here, the teachers are required only to read this text. They are not required to do anything, just to read. It is different from this example, because they get a task here. They need something to do here. So then the purpose of the grid building might be informative or engaging. Informative, you know, when you get the information. But engaging, you need to engage in a task. Okay, summing up, it's possible to say MT's grid building have different ways of enacting. So the connection between scopes was simple, and maybe might be binodal, trinodal. The way of arrange them might be sequential or integrated, and in terms of purpose, it might be informative or engaged. I think this categorization is quite useful because it reveals a kind of MT's expertise that is to connect different scopes of communication, but also it makes visible the ways grid building can be enacted in mathematics teacher education. It's particularly important because there is this strong goal to connect advanced mathematics to school mathematics. In Brazil, for example, the mathematics teacher education programs is a 4-year bachelor's degree. More or less 70% covers advanced mathematics, like calculus, analysis, linear algebra, and in general, in this process, the prospective teachers don't see any connection with the contents they are going to teach. Even when they study real analysis, because in school they are going to teach real numbers, but when they study real analysis, they don't see any kind of connection. So then it's very important to support teachers learn to connect advanced mathematics with school mathematics, because advanced mathematics can improve the understanding in the ways they teach at school. So, for example, this working from a group from New Jersey, Westman and colleagues, they have been working on that. And also, it's very important, teaching should be based on research, maybe in a more explicit way, like doctors do. When you go to a doctor, to get a diagnosis, they follow protocol based on research. So maybe you should get inspiration in that. So then the connection between teaching and the research findings should be more mathematics teacher education. So this idea of hybrid building makes it visible as a way for MTEs to improve the way they support mathematics teachers. This is an ongoing project. Now we are working in improving this categorization, and also we are observing MTs during the classes, during the work, to try to figure out other ways this categorization doesn't represent. So I'm very happy if you have comments and questions. Share.